Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question 4 part B from the October-November 2022 paper 4 variant 1 from the IGCSE Cambridge exam. 4 part A was about simple and compound interest. Now we got questions about exponential increase and decrease. For B is a decrease and A is increase. So I just decided to do them on separate videos. A very similar kind of concept. But it says Xavier, I think I'm saying his name correctly, buys a car for $2,500. The value of the car decreases, so be very careful when you're reading this question, decreases exponentially at a rate of 10% per year. Calculate the value of Xavier's car at the end of 5 years. So we got here exponential decrease. So the way I like to do this, I say, okay, it's a decrease of 10%. So that means its value, if it was 100%, it's going to decrease by 10%. So it's going to become 90% of what it was at the end of each year. Okay, so the new value of his car is going to be the original value multiplied by the multiplying factor, which is 90%, becomes 0.9. And then you just put the number of years, the number of times it's going to decrease. It decreases each year for 5 years, so you put to the power of 5. All right, so for example, if it said each year for like, say 18 months, for example, then you have to convert them to the same unit. You have to convert this to years, basically, right? The number of times it's going to increase or decrease. So if, for example, it said each year, and this was in months, you have to convert the months to years. But if this said each month, and this is in years, then you have to convert the years to months. Okay, so whatever this is, you convert to whatever this is. In this case, they're the same, no problem. Just put 5. Okay, so that will give you your answer. So we take the calculator. So you have 2,500 times 0.9 to the power of 5. And you have your answer, which is going to be 1,476.225. 1,476.225. Now be very careful here. In fact, I should have highlighted this from the beginning. It says, give your answer to the nearest dollar, correct, to the nearest dollar. Right? Many people would say, okay, all right, round to two decimal places because there's currency, and they'd write 1,476.23. But it says to the nearest dollar, the nearest whole dollar, which is going to be 1,476. Okay, if you don't do that, you will lose a mark because they specifically mentioned it here as well. So it's very important for you to understand that, right? And then you should make a little check to see, is my answer sensible? It's decreased. It was 2,500. Now it's 1,476. Now some people by mistake, they might, for example, add instead of subtract. So they might put here 1.1 because they're not thinking straight. They might put 1.1, and then your answer comes out at a value which is greater than what it was. So obviously you think, okay, I've done something wrong because it says decreases. I added instead of subtracted. So it's very important for you to understand. And again, you could use the formula if you want. The formula is the new value is the original value, okay, times 1, and this will be minus, okay, the amount, the percentage decrease over 100 to the power of n. You could use that formula and it would work. You'll have 2,500 times 1 minus, and you're going to have decreases at, it's going to be 1 minus 10, whatever the decreases you put there, over 100, okay, to the power of 5, and that gives you the same thing because this is going to be basically 1 minus 0.1, which is 0.9 to the power of 5 times 2,500, exactly the same thing that we got there. All right, so it'll give you the same answer in the end. I personally prefer to use this rather than memorizing the formula, but that's perfectly fine. So there's part B. Now we're going to do part C. It says the number of a certain type of bacteria, now this time it says increases exponentially at a rate of R% per day. After 22 days, the number of this bacteria has doubled. Find the value of R. Okay, so now basically in this case we know that there's a certain amount that the bacteria was. So let's say that the amount of the bacteria in the beginning was let's just, for this, I think even using the formula will probably be easier. The new value is equal to P times 1 plus R over 100 to the power of n. All right, in this case we know that V is equal to 2 times P. Right, V is equal to 2 times P because the population has doubled. So we can say that 2 times P is equal to P times 1 plus, and R is going to be what we have to find, okay, over 100 to the power of 22. Okay, so now what we can see here is this P and this P will cancel out. If you divide both sides by P, you know they're going to cancel out. So we're left with this formula: 1 plus R over 100 to the power of 22 is equal to 2. So if we solve this for R, we'll get the answer. So the first thing we need to do is we need to take the 22nd root of 2. All right, 22nd root of 2, and we have 1 plus R over 100 equals that. So what is the 22nd root of 2? So we're going to have, we use this button over here for the calculator, which has these 2 boxes, the square root. So press shift in that button. So we're going to put 22 in the root, and inside or underneath the square root sign we put 2. So we end up with this. I'll leave it in terms of this for now. So you have 1 plus R, or you can subtract 1 from both sides. So we have R over 100 is equal to 22nd root of 2 minus 1, and then we can multiply both sides by 100. So it's going to be 100 times the 22nd root of 2 minus 1, and that will give you your value of R. So instead of rounding, we can just leave it in this way. So what I'll do is I'll do 100 times, as I said, the 22nd root of 2, and then make sure it's outside the square root sign, or the root sign, sorry, minus 1, close the bracket, and that will give you your value of R, which is 3.2008. 3.2008 continues. Now, did they say how to round it? No, so we should put it to 3SF, which would be 3.20. So there's the answer to part C. So for part C, I think using the formula makes life a bit easier than using this method, okay, that I used up here, although it would still work, but it's kind of like, you know, makes it a bit more confusing. So using the formula, so that's why it's good to have a variety of methods to use. Okay, sometimes using the formula is easier, sometimes using your, you know, logic is easier, sometimes, you know, you got to switch between the two. All right, so we know that the amount has doubled. All right, so we can say that, you know, the new value is twice the old value. Okay, and then from there you can continue. So there is the answer. Other questions from this paper can be found in the playlist that will appear in this region over here at the end of the paper. Other questions from the topic of percentages in general from this playlist over here, and specifically I'll put a special playlist for exponential increase and decrease over here. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.